Welcome back, Calculus. I hope you all are well. Our objective today is going to be to answer tabular FRQs. So those are FRQs that start out with a table and then ask us different things about that function, typically in some kind of real-life context. So I've got the checklist on the screen for you. You know what to do from here. All right, so there are kind of three templates I am going to teach you today, all three of which tend to pop up on FRQs on the AP exam. So I'm going to force pause on your screen. Can you just copy what I have, and then I'm going to give you the template. Okay, we're back. So our first template is going to be explaining the meaning of a derivative, so f prime of a, where a is a constant, it's typically a unit of time, in the context of a word problem. Okay, so for this, we are going to say at, and again, I'm going to assume a is some kind of time. Okay, so at t equals a, and then units of a. I'm going to put of time. I'm going to assume that a, again, is time. And then you are going to state your function in words, okay? So like if f measures the temperature of T, which we're going to see here in a bit, then you're going to state the temperature of the T is, and then you're going to choose increasing or decreasing, okay? And the way you choose is depending on when your derivative is positive or negative, right? So if your derivative is positive, choose increasing. If it's negative, choose decreasing. At a rate of, and then you're going to put the absolute value of your answer with units. And your units are typically going to be something over something, right? Because you took the derivative, okay? Why do I want the absolute value? Well, because you already dealt with the sign right here, so you don't want to say it's decreasing at a negative value because then it's actually increasing, okay? So I know we've done this one before, but I do want this back in your notes. So go ahead and pause if you would need to copy anything here. Otherwise, we're going to move on to the second template. I'm going to force a pause on your screen. Go ahead and copy what I have, and then I'll give you template number 2. We're back. So for IVT, you use this to show when a function value exists. So if they're asking you for when a function value as opposed to a derivative exists, you're going to use IVT. Do you remember what the conditions on IVT were? It's just that f is continuous, okay? And sometimes this will be a yes or no question. So if you need to say yes, but then you need to state the theorem you're using. So by IVT, since, then you need to say why you can use IVT. I'm going to use f, but whatever your function is called. So since f is continuous, and then we're going to show the math. So whatever number we're trying to prove exists, I'm going to call it capital N for that number, is between two given y values, right? And one of these will be f of a, and the other one will be f of b, where the interval we want that they gave us was a and b. Or we could use anything within that interval as well, okay? So this is template number 2. Pause if you need to write anything down here, and then we will move on to the last template. Okay, I'm going to force a pause on your screen. Go ahead and copy what I have, and then I'll give you the third and final template. So MVT is used to show that a certain derivative value exists, all right? So it's going to follow very similar to that last template, but for MVT, what are our conditions? F is continuous and differentiable, and of course we know that if f is differentiable, it's also automatically continuous, but we don't know that the readers know we know that, okay? So we've got to state both. So, and technically it's differentiable on the closed, differentiable on the continuous on the closed, differentiable on the open, but as long as we state that it's differentiable everywhere and continuous everywhere, we've covered all our bases, okay? So again, if it's a yes or no question, be sure you say yes. Now state your theorem, so by MVT, then state why you can use your theorem. So since f is differentiable and continuous, and then we need to show the math, and remember the conclusion of MVT was this: f prime of c equals f of b minus f of a all over b minus a. And this fraction right here should simplify to the number they're wanting you to show that the derivative is equal to, okay? All right, so that is all. What I'm going to do is, if you are coming in class, I will do the first one with you in class, If you are not in class, I'm going to do a video on the first question of the assignment, okay, and I will post that for you to watch as well. All right, you all, I will see you next time.